right, so this is 11.4, and it's on probability, which is something we talk about all the time. So we talk about, okay, there's a 50-50 chance, or 1 in every 4 people have an interaction that is positive with this business, or whatever it happens to be. There's so many different ways that we use that language all the time. Your chances of winning the lottery are 1 in 538,222,005, whatever it happens to be. So when we're talking about probability, the probability of some event occurring is the number of ways that the event can occur over the total possible ways that things can go. There's a more not elegant way of saying it, but the bottom line is, think of it this way. So there are, let's see here, 1, 2, 3, 4, 5 women in this classroom. There are 1, 2, 3, 4, 5 men. Okay, so what is the probability of selecting a woman out of this classroom? 5 possible ways to select a woman. 10 possible people to select from. So our probability of selecting a woman from our class of people, men and women, is 5 out of 10, or 5/10. We do that all the time, okay? So let's take a look at this one. A 12-sided die is rolled. The set of equally likely outcomes is obviously that, right? They say this, though, because there may be, what if this 12-sided die has 3 sides with all 5s? That's going to change your probabilities, right? Or 6 of the sides are a 1. But in this case, there's a 1 through 12. Each side has its unique number. Okay, it's important for them to list all the possible outcomes. Possible ways, possible outcomes. Does that make sense, guys? Okay, so before we even start, we know that this is going to be out of 12. Everybody agree? Now, find the probability of rolling a 3. So the probability of getting a 3 is how many out of 12? 1. There's only one side that's a 3, so it's 1/12. Does that make sense, everybody? Okay. Now, pay close attention that you need to type an integer or simplified fraction, meaning that if that was, say, 2 out of 12, you would need to simplify that. Does that make sense, guys? Okay, pretty basic. I know I'm spending a lot of time just on this first question, but I want to just drive that point home. Okay, all right, let's keep going. A 12-sided die is rolled. The set of equally likely outcomes is 1 through 12. Find the probability of rolling a number less than 4. Less than 4. Does that mean we include 4? No. It means we include 1, 2, 3, but since it's less than, not less than or equal to, it means how many ways can we roll a number less than 4?
3 out of 12.
3 out of 12, or when simplified, 1/4. 1 out of 4. Does that make sense, guys? So I'm going to take this away. That's 1/4. Everybody got that? Okay, pretty basic. Let's keep going. A 12-sided die is rolled. The set of equally likely outcomes is 1 through 12. Okay, every side has only one number, one unique number. Find the probability of rolling a number greater than 4. Do we include 4? No, because it's not greater than or equal to. It's just greater than. So that's 5, 6, 7, all the way to 12. How many is that?
8.
8 out of 12. Is that the answer? No, because you need to simplify. What is that? 2/3. Now, if you're a little bit rusty with your fractions, let's just make sure you understand this. How do we get down to 2/3? You ask yourself, what is the biggest number that 8 and 12 have in common that we can divide or factor out of it? 8 and 12 both have the number 4 in common, right? So 8 divided by 4 is 2, 12 divided by 4 is 3. So that's how we get 2/3. Now, if for some reason you select a number and you can still simplify after you've divided, keep going, okay? But we don't have that issue on this problem. Okay, how about this one? A 12-sided die is rolled. The set of equally likely outcomes is 1 through 12, all unique numbers on each of the sides. Find the probability of rolling a number greater than 17.
0.
There are no ways to get 17 because your numbers only go to 12. But there's no need to freak out here. It's not a big deal. There are 0 ways that you can get a number greater than 17 out of the 12 possible ways to have this occur, how the die is going to come out, the outcome is going to come out. So simplified, remember simplify, right, would be 0. Because 0 divided by anything is 0. Okay? All right. You are dealt 1 card from a standard 52 card deck. Find the probability of being dealt a 6. Now, there were times when I just assumed that people understood how a deck of cards worked. Let's not assume that. Let's make sure that you understand how a deck of cards works. And so, first and foremost, you need to know that with a standard 52 card deck, there are what? Hearts, right? What else are there? Spades. Or is that clubs? I missed that. That was clubs. Clearly, I don't know a deck. There's my spades. And then diamond. Okay, not an artist. I think my heart's the best one. So if all of these suits make up a total of 52 cards, it means that there should be an equal amount of cards for each suit. These are known as suits. Yeah, so how many hearts are there? How many heart cards are there?
13.
There'd be 13, yes. So there are 13 cards with a heart, club, spade, diamond. Everybody agree? Now within these cards, I'm just going to outline everything right now. Within these cards, of the 13, how many have numbers on them? Do we have a number 1? No, we have 2, 3, 4, 5, 6, 7, 8, 9, 10. So 8 cards have numbers, right? 1 card is an ace, right? And how many cards have Jack, Queen, King? 3. So what are those known as? The face cards. And are we missing anything? So 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, all right, this should be 9. 9, not an 8. Not paying attention. Because you have everything up to 10 except the number 1. This should be 9. Not thinking. So 9, 1, 3. Is that 13 total? Yes. And every suit has this or these as options. Does that make sense, guys? So with that said, once you know your cards and how or your suits and how they're broken up into numbers, ace, and face, then we can answer these questions. You are dealt 1 card from a standard 52 card deck. Find the probability of being dealt a 6. Now, first and foremost, when we're trying to figure out getting a 6, how many possible ways do we have to get a card? Let's look at the bottom. Yes, you're right. How many possible ways can we get a 6? 4, right? 52 total ways to be dealt a card. Does that make sense, guys? So the total possible outcomes is 52. You get 52 possible ways of being dealt your card. In terms of getting specifically a 6, you have 1 from here, 1 from here, 1 from here, and 1 from here for a total of 4. But that's not your answer, is it? because you need to simplify. And what does 4 over 52 simplify to? 1 over 13. Okay, so there you go. The answer 1 over 13, as you can see, 1 over 13, and there it is. Does that make sense, everybody? Okay. All right, let's do this next one. You are dealt 1 card from a standard 52 card deck. Find the probability of being dealt a diamond. Well, let's go take a look at this. First and foremost, how many possible ways do we have of being dealt cards? Just cards in general. 52 again, right? You have 52 ways that you can be dealt a card. Now they ask, what's the probability of getting a diamond? So we need to go figure out the number of ways to get a diamond, which is what? 13 ways to get a diamond. But is that your answer?
No.
Of course not. You need to reduce it, and it reduces to what? 1/4. Good job. Okay, there's the 1/4. Let's move along. Okay, let's take a look at this next one. You are dealt 1 card from a standard 52 card deck. Find the probability of being dealt the Jack of Spades. Is that a very specific card? It is, absolutely it is. So, first and foremost, how many ways can we get the Jack of Spades? Oh, sorry. Yeah, you're right. I jumped around. There are 52 ways to be dealt a card, and how many ways to get the specific Jack of Spades? 1. There's only 1 of them. So you can only get 1 out of 52 in that case. All right, let's take a look at this one. You are dealt 1 card from a standard 52 card deck. Find the probability of being dealt a heart and a diamond. Let me add to that. And a diamond at the same time.
Yeah, this one's tripping out too.
It's 0. And let's explain this. This is not saying you are dealt 2 cards. It's saying you're only dealt 1 card. Because you're only dealt 1 card, there's no possible way a card can have a heart and a diamond on it, nor can you get 2 cards at the same time if you're only being dealt 1. So the answer is indeed 0. There's no way that that can happen. Okay? Very good. All right, let's take a look at this next one. So this next one deals with flipping a coin. Is it still going? Is it still recording? Okay. This deals with flipping a coin twice. Let's talk about this first. If we flip a coin, right? We flip a coin, it could land heads on the first one, and then we flip it again because we're flipping it 2 times. It could land heads on the second. Everybody agree? It could be heads on the first and tails on the second. It could be tails on the first and heads on the second, or it could both be tails. Does that make sense, guys? Okay. So, how many possible ways can we get for flipping our coin? Twice? 4. It's not 8. It's not 8 because your way that it can occur is just it includes having to flip it twice. Does that make sense? Your outcomes are 2 flip outcomes. Okay? So all of your answers for the coin toss where it's tossed twice are out of, let me put it over here, and we'll do this one in a moment, but they're all out of 4. Does that make sense, everybody? Not 8. Because it's not saying a coin is tossed 8 times. And it's not, and that doesn't even work. Because if a coin is tossed 8 times, you basically only have 2 ways that it can occur. You got heads, heads, or heads. Heads for all 8. There's so many different options. Does that make sense? It's not just even 8. You got heads and then all tails. Heads, heads, then tails. Heads, 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 then tails. Heads, 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 and tails. There's so many different ways that it can occur. Okay, so, and then you have all the different combinations of it switching up. So anyways, we won't go into that. So let's actually answer the question. The probability of getting 0 tails. What does 0 tails mean you get? You get 2 heads. What else could you get? Nothing else, right? 0 tails means that you can't even have 1. You guys following me? So this is just what here? 1. So I'll say 0 tails just as like a descriptor here. And there it is. 0 tails, 1 out of 4. You don't want any single tail in your answer. All right, let's take a look at our next problem. A fair coin is tossed 3 times in a row. The set of equally likely outcomes is you could get all heads the first time, 2 heads, 1 tail, heads, tail, heads, tails, heads, heads, and as you can see, the order matters, right? Because if you're flipping it 3 times, it's not just saying, okay, you get 2 tails in there. The order in which it happens makes a difference. How many possible outcomes do we have on here? 8, right? So this is a problem where we have 8 possible outcomes. Let's look at what specific one they're looking for. Find the probability of getting exactly 0 tails. Same kind of question, different context, right? How many is that? 1 again. 1 again. Does that make sense, guys? Any questions about that at all? Okay, so that's it. 1 out of 8. Okay, let's take a look at this one. Well, this is let's do this one. Doesn't hurt. A fair coin is tossed 2 times in succession. The set of equally likely outcomes is, obviously we've already seen that, right? Find the probability of getting a head on the first toss. How many ways can we get a head on the first one? 2, right? So there are 2 ways that we can get a head on the first toss. So that's 2 out of 4, or simply 1/2. Does that make sense, everybody? Any questions about that? All right, good. Now, on to the next scenario. You select a family with 4 children. If male or M represents a male child and F is a female child, the set of equally likely outcomes for the children's genders are, we could get all girls, girl, 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 then a boy, girl, girl, boy, girl, all the way down to all boys, all males. Does that make sense, guys? Your first step always in a problem like this is to count up all your possible outcomes. How many are there?
16, I think.
Okay, let's double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So immediately, your answer should have 16 as the denominator, okay? Now, let's go figure out what kind of event they're looking for. Find the probability of selecting a family member with exactly 4 female. They're given all the easy ones. How many is that? 1. I don't like the previous 3 problems that we just did because they're too easy. Let's move along. I don't want to do this one. Exactly 0 female children. That means you're looking for what?
0.
All males.
Oh, all
It's 1
males,
out of
sorry.
16 on this one. That's okay. All right. Let's take a look at this one. Okay. Actually, you know what I want to do? Let me back up just for a moment, just to test you guys. Let's change the question here on this one, shall we? Find the probability of selecting a family with 2 female children. How about this? Let's make it better. With
At least
2,
or just 2?
let's do at least 2 female children. At least 2.
10 over 16. 10 over 16.
Let's take a look. That's good. 1, that one works, right? 2, 3, 4, 5, 6, 7, 8, 9, 10,
Oh.
11. Then none of these count. So it would be 11 out of 16 because these are 1 girl and none. So 11 out of 16 for that one. Okay, now we've done one that's not just a 1 or a 0. All right, let's go to our dice. Okay, so this problem says a single die is rolled twice. There are 36 ways that this can come out. And let's understand this chart here. because this can be a little bit tricky. So the way that they set it up is that the left column here is the first roll, which means the first coordinate here always represents what could happen on the first roll, okay? This is your second roll. It got cut off. So second roll, and the second part of your coordinate is what could happen on the second roll. So for example, we have on a dice, it has 6 sides. So you have 1, 2, 3, 4, 5, 6 as each of the pieces. And so if you could roll a 1 and a 1 then a 2, a 1 then a 3, you could roll a 4 then a 4, you could roll a 5 then a 4, all the way down to rolling a 6 and a 6. If you count these, because it's 6 by 6, there are 36 possible ways that this can happen. Does that make sense, guys? Meaning that for your probabilities, they all should have 36 in the denominator. Does that make sense, guys? Okay, so let's go answer this. Find the probability of getting 2 numbers whose sum is 2. I don't get why they're doing the easiest ones here. This is crazy. It's 1 out of 36, right? Because the only option to get 2 numbers when you roll them, when you add them together is 2, is just what? 1 and 1. I don't like this. It's too easy. Let's do this again. All right, here we go. Same situation, right? Different question. Find the probability of getting 2 numbers whose sum exceeds 15. Oh, another one.
Yeah.
0. This one's dumb. Because the greatest sum is what?
12.
12. I hate these problems. They're giving you all the easiest ones. How about this? Let's do our own. Okay, we know this one is 0 because the highest it goes is 12, because when 6 and 6 is added, it's 12. So there's no way to get something whose sum exceeds 15. How about this? Find the probability of getting 2 numbers whose sum is 7 or greater.
Okay, 7 or greater.
It is 21. Let's talk about this. And so this right here in the diagonal all adds to 7. Everybody agree?
Yeah.
And then that means everything beyond it would add up to 7 or greater. Does that make sense, guys?
Yeah.
There are 6 items in this diagonal. Then there's 5. Then there's 4. Then there's 3, 2, and 1. If you add them all up, it's 21. Does that make sense, guys? Now, let's ask another question. Find the probability of getting 2 numbers whose sum is exactly 7. 6 out of 36, or 1/6. Does that make sense, guys? Okay, let's move on. Okay. All right, to the really, really easy questions. All right, let me erase this because we are pretty easy. Here, so if you can't see the colors, they're described red, 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 brown, brown, blue, blue. Oh, there's another brown, right? Yellow, yellow. Does that make sense, guys? Okay, so here's the question. It says, use the spinner shown to answer the question. Assume that it is equally probable that the pointer will land on any one of the colored regions. If the pointer lands on a borderline, spin again. Okay, that's not really relevant here. Okay, if the spinner is spun once,
3 out of 10.
find the probability that the pointer lands in a red region. Well, first and foremost, we need to know how many possible ways that we can land on anything, which is how many? 10, right? There are 10 equal spaces. So you need to make sure you account for that. There are 10 ways that this can happen. A red region makes up how many of them? 3. So your probability is 3 out of 10. Does that make sense, guys? Okay. So 3 out of 10. And let's roll one. Should have another spinner. Here's another spinner question. Use the spinner shown to answer the question. Assume that it is equally probable that the pointer will land on any one of the colored regions. This one's a little bit more simple because one, there are fewer regions, and two, there are fewer colors, okay? Find the probability the spinner lands in a red region. 3 out of 6 or 1/2, right? There are 3 red regions out of 6 total regions, so it's 3 out of 6 or 1/2. You must always simplify. Okay, let's take a look at this one. You know what?
You're done.
Well, no, I should
You're
do
done.
this one. Let's do this one. If the spinner is spun once, find the probability that the pointer lands in a region that is blue or brown. Blue or brown.
5 out of 10.
Is it 5 out of 10? Now, question, why isn't it 0?
Because it says or.
You got it. The word or. If it says and, you can't do that because you can't land on both at the same time, but or is okay. So 5 out of 10 or 1/2, is that what we said? All right, there it is. Good job, guys.
That's why I said, blame me if you get it wrong.
It's okay. All right, I am going to say, okay, brown and blue. 0. See, it says and right here. 0. No way.
How dare they try and trick us?
Tricky. Sneaky. All right, let's take a look at this next one. Okay, so the table shows the number expressed in millions of citizens who moved in 2004, categorized by where they moved and whether they were an owner or a renter, okay? Find the probability expressed as a decimal rounded to the nearest hundredth that a randomly selected citizen who moved in 2004 was an owner who moved within the same region. Now, before you actually can even do anything, what you have to do is you have to find out your totals. Remember I said that this was one of the most important things that you knew right away was the total possible ways. Well, you have to actually figure out your totals. To figure that out, you need to add all of these together. Okay, so let's first get our numbers of the total number of owners who moved to various places. Somebody tell me that. And I'm going to go ahead and erase this because we're pretty much done with that. Is it still recording? Excellent, thank you. What do you got? 12.4, 14.4, 14.7?
38.9.
38.9?
Unless I did it wrong.
For the total right here?
6,
This is 19.2, 23.2, 24.2. And so the total is what? 38.9? Does that make sense, guys? Why is it important that we add these two together? Because it tells us the total number of owners and renters who moved, which means that this number is going to be what? Our denominator. Does that make sense, guys? So when you do this problem, you have to know the total possible ways that things can occur, your total possible outcomes, and that means you have to add up all the owners who moved in different scenarios as well as all the renters who moved in different scenarios. And then you have to add those to know the total for both owners and renters. Make sense? Okay, now let's go to their specific question. Find the probability that the citizen was an owner who moved within the same region. Well, let's go to this. Owner, same region. There it is. And so,
0.29.
0.29.
Or
Round into the nearest hundredth. Is that round to the nearest hundredth?
0.30.
0.30. Okay. Do we have an agreement, everybody? Or no?
Yeah.
Yes? Okay. So 0.30. There it is. Good job. Does that make sense, guys? This one can be tricky if you don't know that that's what you need to do, but there you go. No problem at all. All right, I'm going to leave 21 for you. That's your little bonus one. No big deal. And that concludes 11.4. So that's due next. All right.